Hi everybody. This is really a nice exercise we get to show you now. It's a classic question. Given 3 points, find the equation of a circle. For any 3 non-collinear points, there's always exactly one circle that contains them, or that passes through them. Let me just show you a little instance of that with a compass for a moment. I'm just going to show 3 arbitrary points. I've not planned this, not a little. I just know how this works. I'm going to call that point A, this one B, and somewhere over here, we can put it anywhere you want. I'm going to call this place over here C. They have to be non-collinear, and I know there is a circle that passes through these 3 points. I'm going to find that circle with you. Got to show these segments first, and I'm going to show segment AC, and watch what I can do with that. There is a set of points that is equidistant from A and C, and that would be all the points along the perpendicular bisector. And I can do a perpendicular bisector with a compass. I'm going to whisk through it really quickly. I'm going to sweep a pair of arcs on one side, one from either endpoint, and the same thing on the other side of that point, of that segment AC. Just a pair of arcs, one from either endpoint, so that they cross each other. And when I do that, I've set up the perpendicular bisector of segment AC. Every point along this line, let me bring it out long, is equidistant from the endpoints of that segment. We've discussed that earlier in the year, and pretty much for this reason. Every point along this line is equidistant from A and C. I'm going to do the same thing with AB. Show that segment. You're not going to do this with a compass yourself. You can do this with algebra. The compass is a nice thing, and if you got a compass, then this is something you can do. I'd be happy to see you doing it. I'm going to sweep arcs on both sides from both endpoints. That'll be a point on my perpendicular bisector, and do the same thing on the other side. As best I could. And here comes another perpendicular bisector. There, through there. Something like that. I'm here to tell you, if this is a perpendicular bisector, every point along this line is equidistant from A and C. And if this is also a perpendicular bisector, then every point along this line is equidistant from A and B. So what about that place right there? I just called it Z. That's the center of our circle. It is equidistant from A and B and C. And let me see if I can't make that happen. Whisk my circle out so it touches that C, and this should be pretty close. It ain't going to be perfect. Nothing ever is. But you see, it comes pretty close, doesn't it? So given 3 points, we can find the equation. We can find the circle that passes through those 3 points. But we're going to do that with some algebra. And as we start thinking about that algebra, let me back up a little, give you a look at this. No, the other way. There's some formulas I'm going to need. To do this, I'll need the slope formula, midpoint formula. You write them down if you need them. You're going to need to know them. You'll need to know the distance formula. We're going to have to write equations of lines, and the point slope formula is a great way to go. And then we're going to graph lines, and the slope intercept formula will be the thing that the tool will need. We'll know the slope and the y-intercept. And we're going to talk about the equations of a circle. So these 1, 2, 3, 4, 5, 6 formulas are part and parcel of what you'll need to do this exercise. And here we go. I think we'll do it this a couple of times. I have 4 of these pages written, and we'll use 2 for this assignment and 2 for the next. I'm going to start off by graphing these 3 points. I won't make you watch. I found A over 4 and up 4. B was left none, but down 12, way at the bottom end of that axis. And point C, I went left 4 and up 6. Now I'm just going to follow instructions here, but I know what we're going to end up doing is I'm going to get the perpendicular bisector of 2 segments. Like when I was finding the equation of this circle a moment ago. I'm going to do the perpendicular bisector of 2 segments, but I'm going to do that algebraically. We're going to start with segment AB. Let me show segment AB. There's going to be a line that is the perpendicular bisector of it. It's going to look something about like that, but we're going to figure its equation. First thing I need to know is the slope of segment AB. I think I can probably use some of this space to make that happen. A was at 4, 4, and B at 0, negative 12. What do you think about the slope of AB? Going to be positive or negative? Or going to be a big number or a little one? You got to be able to make that decision ahead of time. Looks to me like a pretty big positive amount, like 3 or 4 over 1. Let's see how that's going to look with 4 y coordinate minus negative 12 over 4 minus 0, giving me a positive 16 over 4. Yeah, we got a slope of 4 over 1, don't we? Slope of AB, 4 over 1. What about the slope of a line that's perpendicular to AB? I'm sure that's going to be important to us. This is the segment AB. That's what I want to think about. It would have the negative reciprocal slope, a negative 1/4. Lots of things from the first semester come to play now. In the midpoint of AB, I think I can make that fit right here. I'm going to add the x's and divide by 2, add the y's and divide by 2. The segment AB, 4 plus 0, divided by 2, and 4 plus a negative 12, divided by 2, yielding a midpoint at 2, negative 4 plus a negative 12 be a negative 8, divided by 2 be a negative 4, huh? But I make mistakes and my phone's going off. I'm going to graph that point, see if it looks like it's where the midpoint ought to be. Over 2 and down 4. Yeah, that looks pretty good. I should have tested that slope too. Does it look like it's going up 4 and over 1? I'm thinking, yeah, that looks okay also. I think our calculations are good so far. But you want to check those things all the time. Now I'm going to get the equation of that perpendicular bisector of the line that is equidistant from A and B. Something along there. I'll use this formula, y minus y sub 1 equals m times x minus x sub 1. Friends, this formula won't go away in your life. It's throughout this class, it's going to be throughout the next year's class and the one after that. So it's just part and parcel of what you got to know. We're going to go through the midpoint, and we're going to have that perpendicular slope. So y minus the y coordinate, negative 4. I'm going to call that, instead of y minus a negative 4, y plus 4 equals, and with the perpendicular slope, negative 1/4 times x minus the x coordinate of that midpoint, 2. Got a couple things to work on there. I'm going to keep that y with plus 4 on the left-hand side. Multiply through those parentheses, and I got a negative 1/4 x. And a negative times a negative is going to be a positive, and a fourth of 2. What you got for a fourth of 2 is a half, huh? Let me subtract 4 from both sides. As I seek to get y by itself on the left-hand side, I get y equals negative 1/4 x. I have a positive 1/2 minus 4. I think that gives me a negative 3.5. You think that through the way you need to. But let's graph that line. Y-intercept of negative 3.5, 1, 2, 3.5, right about there. Did I miss something? And a slope of down 1 and over 4. Down 1 and over 4. This isn't perfect, but it's looking pretty good, I guess. I'm thinking that line should look about like this. I'm saying, declaring that to be the perpendicular bisector of segment AB. Something about there like that. Yep. Got to get the equation of the perpendicular bisector segment AC now for this segment. I'll need the slope of AC. What do you expect for that slope? Positive or negative? Big number, small number? I'm thinking like a negative 1/4, negative 1/3, something like that. But we'll see. Let me get those couple of points. I'll work it in this space right here. I'm using A and C. A is at 4 comma 4, and C is at negative 4 comma 6. Graded a million of these kinds of papers, and getting the wrong points going back and forth is it's an error we want to avoid. Let's write them down and go to work there. So I need the slope. Y coordinate 4 minus y coordinate 6 over x coordinate 4 minus x coordinate negative 4. 4 minus 6 gives me a negative 2 over 4 minus the negative 4 is a positive 8. Yeah, we got a slope of a negative 1/4 there, huh? And that's okay. This looks like it could be down 1 and over 4. I think that fits. We'll need the midpoint, won't we? Let's get that too. I'll need the midpoint of AC with these points. So add up those x coordinates and divide by 2. Add up those y coordinates and divide by 2. You can write it down if you want to, but I think that midpoint's going to be at 0 comma 5 over 0 up 1, 2, 3, 4, 5, right around there. Huh? My graph is less than perfect, but that's looked like the midpoint there. Okay, so slope of AC was negative 1/4. The midpoint of AC was at 0 comma 5. The slope of a perpendicular to AC, well, that'd have a positive slope, wouldn't it? The negative reciprocal of this, positive 4 over 1. Now I'm going to get the equation of that perpendicular bisector. It's going to have that perpendicular slope, and it's going to go through that midpoint. And it's going to use this formula. Y, let me start again. Y minus y sub 1 equals m times x minus x sub 1. Through this point with that slope. Y minus 5 equals, for the slope, 4 times x minus the x coordinate 0. The x coordinate of that midpoint. So multiplying there, we got adding right here just y minus 5 equals now multiplying just 4x. Huh? Bring that negative 5 to the other side, and we got y equals 4x plus 5. Let's graph it, see if it looks like it's doing what it's supposed to do. Got a y-intercept of 5, and that's a good thing. It hits right there. And from there it has a slope of 4. I should go up 1, 2, 3, 4 over 1. Show that line best I could. Here's what we should be thinking. All the points along this line are equidistant from A and B, and we've got that equation. All the points along this line are equidistant from A and C, and we've got that equation. This place where those two lines intersect each other should be equidistant from A and C and B. That should be the center of our circle. But how are we going to find that point? We've got to figure the place where these two lines intersect each other. How do you perform that algebraically? You set the two equations equal to each other. Let's do that now. Negative 1/4 x minus 3.5 is equal to 4x plus 5. I know that I ought to shut the video down, and you ought to have some time to work on this equation. I'm going to do it right this moment. I'm going to collect my x's on the right hand side. I would add 1/4 x to both sides, which would give me 4 and 1/4 x right there. And when I bring this 5 to the other side, it will become a negative 5. I should combine it with that negative 3.5. That would give me a negative 8 and 1/2. So just collecting like terms, getting my x's together on the right and my constants together on the left, got this. Looks like x is going to be negative 2, doesn't it? Maybe you don't see that, but how many 4.5s, how many 4.25s are there in 8.5? Let me go over the improper fraction here. This number is negative 17 over 2 is equal to 4 times 4 is 16 plus 1 is 17 over 4x. These equations are the same equation. I'm going to eliminate that coefficient there by multiplying both sides by 4/17. On the right-hand side, the 4's would cancel, the 17's would cancel. I'd just be left with x. Here, the 17's cancel, but I've got a negative 4 over 2. Yeah, I got a negative 2 there, don't I? So I'm thinking, yeah, they cause that negative 2 comma something. Could the x-coordinate of that be negative 2? Now, you could guess at that y-coordinate, but we ought to figure it out. In fact, I could set it into this equation or into this one, and we'll do both, and we're going to see that they both give us the same y-coordinate. If they don't, then we got a problem. Let x be negative 2 in this first equation. Y is equal to negative 1/4 times negative 2 minus 3.5. That would be a negative times a negative. It's going to be a positive. And 2/4, 1/4 times 2 is 2/4. That's like a half, huh? Minus 3.5. That is 1/2. Minus 3.5. That's a negative 3, isn't it? So that makes me think that this place should have been left 2 and down 3, and I'm taking that. But what if I would have used it in this equation? Might have been simpler, huh? Y equals, I'm just going to let x be negative 2. 4 times negative 2 plus 5. Y is equal to negative 8 plus 5. Yeah, y is equal to negative 3. You don't have to do that twice. I'm just showing you that it would have worked either way we go. So we have found the coordinates of that point. It's that negative 2 comma negative 3. Yep. So now, find the radius of the circle and the distance from the center to any of the 3 points. That would be the radius. And we ought to do this every time. You got to check this out. I want to find the distance from that center. The center was at negative 2, negative 3, to any one of these 3 points. I'll do it to B. Just chose it arbitrarily to 0 comma negative 12. I'm going to hit that with a distance formula. Square root of. In the first pair of coordinates, in the first pair of parentheses, the difference in the x-coordinates. You can write negative 2 minus 0. I'm just going to write 2. I know that's the distance between those two coordinates. And for the difference in the y-coordinates, how far is it from negative 3 to negative 12? That's a distance of 9. And when I work on this, I got 2 squared, I got 4. And 9 squared, I got 81. So I got the square root of 85. That's a funny number. Let's do it again. I'm going to do it from that same center point, which we knew to be at negative 2, negative 3, to some other point. And I just did it then to point B, but we could do it to point A, 4 comma 4. And I better get that same radius. That this place better be equidistant from those 3 other guys. Let's hit that with the distance formula, get a look at it. The difference in the x-coordinates is going to go right here. Now you can write negative 2 minus 4, but I'm going to think how far apart those points are, and they're different by 6. And then how far apart are these y guys too? From negative 3 to positive 4 is a distance of 7. I got to square that. So I got 36 plus 49, huh? Hey, that's the square root of 85, isn't it? And that's a number a little bit bigger than 9. But they certainly do agree. And had you done the distance from negative 2, negative 3 to the third point C, it would have come up the same. I invite you to do that. I know the radius. It's the square root of 85. Here's a little something I might as well do since this point is equidistant from those 3 points, since I happen to have my compass. Let me show that circle. I'll measure the distance to point A and hope that that's going to be the same distance to point C. Oh, I'll get that right now. Same one to point C as it is to point A, as it is to point B. Doing the best I could. Yeah, there's a circle that passes through those 3 points, huh? And we ought to write its equation right there. You ought to write it before I do. You'll have to know a couple of things, huh? You'll have to know where the center is. You have to know what the radius is. You have to know how the equation of a circle looks. This one, this equation, x minus negative 2, that'd be x plus 2, huh? Quantity squared plus y minus negative 3, therefore y plus 3. Quantity squared equals, and the square root of 85 squared, just 85. I'd like to show you something else. I want to graph this darn thing. Let me get a calculator. We'll talk a little how that's going to have to happen. This calculator, and the calculator that you got, I don't care which kind you have, it's all going to be this way. These things only graph functions. This is a function graphing machine. This is not a function. Why is it not a function? Because a vertical line crosses it twice. If I put in a value of 4, I'm going to get this output for y or that output for y. I got two different outputs for the same input, so that's not a function. So this, I have to do some special case work to make this happen. But I can make that happen. I'm going to write this on another piece of paper. X plus 2 quantity squared plus y plus 3 quantity squared equals 85. I've got to solve that for y. I'm going to have to say y equals. When I can make that happen, I know what y equals, then I can graph with this machine. First thing you got to do is expand these. You got to multiply x plus 2 times x plus 2. And man, I got that figured out. I hope that you do. And y plus 3 times y plus 3. I got to know what those things are. Square that. Multiply x plus 2 times x plus 2. That'll be x squared plus 4x plus 4. Then you got to multiply y plus 3 times y plus 3, man, and I hope that you got that act figured out. That's going to be y squared plus 6y plus 9 equals 85. Actually, yeah, I think that's probably a pretty... I didn't need to square that one. I just needed to square this one. Let me keep that y plus 3 quantity squared just where it sits, just like it was before. I don't think I needed to square that. But bring all of this to the other side. And what would you then have? Oops, I don't think we needed to expand that y plus 3 squared. I was just looking at it a little bit, and I think I can do that without expanding anything. I still got to solve this for y. I'm going to do that right now. It's the same equation, but I had a moment to think about it. I've still got to solve it for y. I got to say y equals and solve everything else over there. I'm going to leave that y plus 3 quantity squared on the left hand side, and just bring this x plus 2 quantity squared to this side, and this would be 85 minus x plus 2 quantity squared. Haven't done much, but to get the y out of here so I can set it equal y equal to this, I have to take the square root of both sides. And that's an interesting thing. The square root of this thing squared is just going to be y plus 3 equals. And here's an interesting thing you're going to learn. When you take the square root of both sides of the equation, you have to write plus or minus here. I can go into that, but I'm going to delay that right now. Plus or minus the square root of 85 minus x plus 2 quantity squared. Got to get y by itself completely on the left hand side. Got to make it look like this so I can put it on my calculator and graph it. Y will equal, I'm going to bring that positive 3 to the other side, and you ought to lead with a negative 3 plus or minus the square root of 85 minus x plus 2 quantity squared. Now, remember, this was the circle that we found the equation of here. I'm going to graph this on my calculator now, and it'll look something like that. We'll take a look at that right away. Give me a look. See what I had on my calculator already. It's a pretty good looking thing. Make a zoom 6 standard graph. We'll see what that would have done. Oh, well, that's not why we're here. Let me just take a look at that graph. Oh, I see. take another look at that. Sorry to eat your time up. I just thought this was kind of more interesting than what we were doing. Well, we won't fret about that any longer. Let me clear that junk. I'm going to put this on my calculator. I got to start with -3. I'll go plus for this one, and then the square root of 85 minus. Notice when I hit the square root of, mine opens parentheses right away. You just got to stay inside of that radical, minus, and then I got to put another pair of parentheses, x plus 2. Square that, and then close both pairs of parentheses. And from my window, I'm going to say zoom 6. I'm just going to say, let's see what that does for me. And you say, well, I don't know, mister. Is that really that circle? Just give me a minute. Let's play some more. Put the bottom half of that circle, and that'll be the 3 minus the square root of those kinds of things. One with plus and one with minus. Make that happen. Y equals -3 minus the square root of 85 minus, parentheses, x plus 2 squared. Now I'll close those parentheses. And I'll say, show me that graph. And it doesn't really show me happily. I mean, it doesn't look like a circle to me. It looks like an ellipse. But here's the problem. This distance is 10, and this distance is 10. And really, this distance is a lot longer. So I'm going to have to work with that window. Let me just play around for a second. I'm going to go from, say, let me go for x's from -15 to +15. And for the y guys, I'm going to go from, let me think about that some more. I'm going to take that from -20 to +20. And make the y guys go from -15 to +15 since they were shorter. We'll see if we can get a better look at that circle. Oh goodness, what have I done? Let me go back to that window. I apologize. My y minimum should have been a -15. I apologize. There we go. Now let's take another look at that circle. There's still some things we want to talk about there, but could that be the circle whose radius is the square root of 85, and that's what we thought, and that would be a little bit more than 9, and whose center's at -2, -3? I'm thinking that's probably right. And you say, well, why does it have these empty spaces if it's truly the equation of that circle? And because this machine only graphs functions, and that part of that circle is so nearly vertical at those two places that the function machine says, no, I'm not going to graph that. It's a vertical line. It's not a vertical line. It's very close to being vertical, though. So that's why that graphs that way. Isn't that interesting? I'm sorry I made a couple of mistakes, but I think generally you see what's going on there. You can manipulate this equation and put it on a calculator. Don't need to right away, but I just thought I could. Thank you.